In this experiment, the startup code is been explained. Opening the startup.s and selecting the configuration wizard, we can see the sizes of the stack for each mode is defined here, which can be changed by the user. Building this program and starting the debugging and the simulation. The contents of the R13, that is the stack pointer, is highlighted, and the contents of the current program status register is shown. Since the thumb bit is 1, that means the instruction are thumb instructions of 16 bit, and mode is 0x10, that is 10 in hex, that means the mode is user mode. Starting the debugging, we can see that the contents of the program counter are changing. Here is a function called stepping into this function and executing. We can see that the stack pointer contents are changed, as well as the PC is loaded with the address of this function. Executing it, we can see that the PC contents change, and on returning, again the stack pointer content is changed and the PC is loaded with the address of the instruction next to this function. Now let us understand the startup code. This is the standard definition of mode bits and the interrupt flag in the program status register as shown. For example, 10 in hex is for user mode, and I bit and F bit are being set or cleared. The stack size for each of the operating mode is being defined. The different peripherals are being initialized. For example, the BPB, DIV, the phase lock loop, the memory accelerator module, the external memory controller, etc. Here, the startup code is linked to the address where it is expected to run. This is the vector table. So whenever an interrupt occurs, for example, if a software interrupt has been occurred, the execution reaches this vector table, and since it is a software interrupt, the software interrupt address consists the address of the interrupt service routine for the software interrupt. So therefore, the address of the interrupt service routine is copied into the PC, and again stepping over after this statement is been executed, the execution reaches the interrupt service routine function. Similarly, for all the interrupts, the vector table is defined. This is the reset handler, the code to handle the reset. These are the instructions to set up a stack for each mode, for undefined instruction mode, for abort mode, for fast interrupt mode, etc. And in disassembly, the assembly language programs assembly language instructions for each of the C language instructions is shown.